Today's notes are all about solving equations, and really the notes that we take for the next week or two, we will be working on solving equations. Today we are solving what is called one-step equations. Solving one-step equations. Example 1 asks, is x equals 4 a solution to this equation? So we have an equation here, we have an equal sign. Two expressions connected with an equal sign. It wants to know, is x equals 4 a solution? Quick definition here, a solution is a value for the variable that makes the equation true. So is x equals 4 a solution to 3x minus 6 equals 2 times the quantity x plus 1 minus 4? And again, a solution is a value for the variable that makes the equation true. Basically, it wants to know, if I plug in 4 for x, if x is 4, is this a true equation? So we're going to plug in 4 for x and see if it's a true equation or not. So I would have 3 times x, but instead of x, remember I'm putting in 4, minus 6 equals 2 times the quantity x, I'm putting in 4 for my x, plus 1 minus 4. And now we just have an order of operations problem. We really have two order of operations problem. My equal sign's right here. I'm going to work on this side, and I'm going to work on this side, and I'm going to see if those two things are true. So when I'm doing this side, I've got 3 times 4 minus 6. Remember, order of operations, we do parentheses and then exponents, and then we multiply or divide, and then we add or subtract. So I have no parentheses on this side. I do have parentheses here, but it's just a 4 inside. No exponents. Multiplication or division's next. So I do 3 times 4 is 12. I copy everything else down. Now 12 minus 6 is 6. On this side, I do have parentheses. I have something to do inside the parentheses. I have 4 plus 1 is 5. Everything else I copy down. Now it looks a lot like that. I do the multiplication next, 2 times 5. Ten minus 4 is 6. And notice when I plugged in x equals 4, this side is 6 and this side is 6. This is a true equation. Therefore, yes, x equals 4 is a solution to that equation. If I had simplified this side and I got 6, and I simplified this side over here and I got 8, and it said 6 equals 8, then no, whatever I plugged in would not be a solution. A little bit of vocabulary here before we get into solving one-step equations. The first is the solution of an equation. We actually just defined that, so if you just wrote it down from the last slide, you don't need to write it down again. But it is the value or values, we could have more than one solution, of the variable that make the equation true. Almost word for word what we wrote on the previous slide. The value of the variable that makes the equation true. Equivalent equations are equations that have the same solution. Equivalent equations are defined as equations that have the same solution. And inverse operations. Inverse operations. Remember, operations are things you do with numbers, adding. You could subtract them. You could raise them to an exponent. You can multiply them, divide them, root them, square root them, or cube root them. Inverse operations are two operations that undo one another. Some examples of inverse operations, ones that you are familiar with, are addition and subtraction. Subtraction will undo addition. Addition will undo subtraction. There is one example of inverse operations. The other one we will use a lot, starting in the notes today, multiplication and division will undo each other. Division undoes multiplication, and vice versa. Another one we've talked about in this course, and you should be familiar with, are exponents and roots. So an example there would be like if I square something and if I square root something, those are inverses of each other. Or if I cube something and cube root something, or raise something to the fourth power and take the fourth root of something. The two that we will be dealing with a lot are the top two. We'll be worrying about exponents and roots too much yet. But you should know addition and subtraction, multiplication and division. Those are a couple examples of inverse operations. Example 2 asks us to solve directions. I probably should have put them on there. Let's call this example 2. And the directions ask us to solve. Solve simply means find the solution of. We want to find the solution. And we are given the equation x plus 3 equals 5. My guess is almost everybody can figure out what x is without doing any work. I want you to be in the habit of doing the work in a specific way so that when the problems get more difficult here over the next week or two, we've got kind of the steps on how I show my work down. So what we're always going to do is we're going to draw a vertical line right through my equal sign. It's going to look just like this. And the reason for that is anytime I do something on one side of my equal sign, I have to do exactly the same thing on the other side. And drawing that line, make sure I'm doing it on one side and the other side. So you always want to think about what's happening to our x. In this case, I am adding 3 to x. I need to cancel that out. I need to undo that adding 3. Well, we just said that adding and subtracting are inverses of each other. So to undo adding 3, I am going to subtract 3. And that will give me x by itself on this side. If I subtract 3 on this side, I have to subtract 3 from the other side as well. Plus 3 and minus 3 cancel. So on this side, I just get x. This side, I have 5 minus 3, which is 2. And I bring down my equal sign. And now I have x by itself. X equals 2. That is our solution. You can very quickly check that either in your head or by writing it down on your paper. If I plug in 2 for my x, it says 2 plus 3 equals 5. And we can all verify that 2 plus 3 is indeed equal to 5. Part 2 of example 2 gives us 6 equals x minus 4. 6 is equal to x minus 4. Start by drawing that vertical line through our equal sign. Notice the x is on the right side this time. This does not change anything. What are we doing to x? We're subtracting 4 from it, so we need to cancel out that minus 4. We cancel subtraction with addition. We are going to add 4 to both sides. On the right side of our equation, minus 4 and plus 4, those cancel each other out. And I bring down my x equals 6 plus 4, which is 10. 10 equals x, x equals 10. Those are the same thing. Again, you can verify. 10 minus 4 equals 6. Sure does. Number 3. Example 2, part 3 says 3x equals 15. 3x equals 15. Hopefully we remember, if I have a number next to a variable and there's no symbol in between, this means 3 times x. That's multiplication there. We are multiplying 3 times x equals 15. Well, we previously said that the inverse of multiplication is division. So, whoops. So to cancel out this multiplication, I am going to divide both sides. So again, I'm going to put my vertical line there. And to cancel out the multiplication, I am dividing both sides by 3. 3 divided by 3 cancels, and I've just got my x equals 15 divided by 3, which is 5. X equals 5. Number 4, x over 5 equals negative 2. X over 5 equals negative 2. This is the more common way of writing division. I suppose every once in a while it's possible you might see it written like that. But really in algebra class, you'll see division written as a fraction bar more often than not. So x is being divided by 5 here. We cancel out division with multiplication. You're going to multiply both sides by 5. 5's cancel. X equals, probably should have drawn my vertical line, negative 2 times 5, which is negative 10. And as always, we probably should be checking these. 3 times 5 does give me 15. Negative 10 divided by 5 does give me negative 2. Example 3. Example 3, again, asks us to solve part A says x minus 3 equals negative 8. X minus 3 is equal to negative 8. I draw my vertical lines for my equal sign. Think about what's happening to x. We're subtracting from x, so we cancel out subtraction with addition. I can bring down my x equals negative 8 plus 3. And this is why we work so hard on adding and subtracting integers. Because you can do all of the algebra correct. We can get all of the steps correct in solving the equation, but if I can't add and subtract integers correctly, we're going to get the answer wrong. Negative 8, that's negative. Positive 3 is positive. 1 positive, 1 negative. When I combine them, I want to subtract. 8 minus 3 is 5. The bigger number was negative, so x equals negative 5. R divided by 4 equals negative 10. We just did one very similar to this. The inverse operation of division is multiplication. I need to multiply by 4 to cancel the division. If I multiply this side of my equation by 4, I have to multiply this side of the equation by 4 as well, giving me R equals negative 40. And last one, not last one, sorry. It is the last one. It says negative 18 equals x plus 3. Negative 18 equals x plus 3. We draw our vertical line straight down. We want to subtract 3 from x to cancel out that plus 3. When I subtract 3 on this side, I need to subtract 3 over here as well. And again, we need to combine integers correctly here. Negative 18 minus 3 is negative 21. Sorry, one more. Promise, last one here. 3/4 x equals 9. 3/4 x equals 9. I'm going to put this one on the new slide. 3/4 x equals 9. We talked about before a number, a variable next to each other. That's multiplication. That's times in there. I cancel multiplication with division, so I need to divide by 3/4. If I divide this side by 3/4, I have to divide this side by 3/4 as well. So these cancel, and I get x equals 9 divided by 3/4. Well, we've been working on dividing by a fraction. If I divide by a fraction, I keep, change, flip. Keep the 9, change the division to multiplication, flip the 3/4 to 4/3, and then when we multiply fractions, we multiply straight across. I don't have anything on the bottom here. That's the same thing as a 1. So 9 times 4 is 36. 1 times 3 is 3. And 36 divided by 3 is 12. X equals 12. Probably shouldn't have circled this. X equals 12.